Welcome! In this lesson, we're going to get into how programmers actually test their code. We'll be looking at something called test data. And by the end, you'll have a really clear idea of how this makes all the apps and games you use way more reliable.
The short answer is something called robustness. It's a huge deal for anyone writing code. And today, we're going to dig into how they achieve that robustness using careful, planned-out testing.
So here's what's on the agenda. We'll start with what a robust program actually is, then look at why testing is so important. After that, we'll get into the details of test data and the 3 key types you need to know. And we'll finish up with a look at what this means for your exams.
All right, first things first. What do we even mean when we say a program is robust? It's a really key idea, and it's got less to do with cool features and more to do with just being stable.
So a robust program is one that's built to handle mistakes. When a user does something wrong. Think of it like a really well-built bridge. It's designed for normal traffic, sure, but it's also built to handle a surprise storm without falling apart. It's all about how it reacts to the unexpected.
Okay, so if that's the goal, how do programmers actually build these super stable programs? Well, that brings us right to our second point, why they test. It's really all about finding those problems before anyone else does.
Testing isn't just messing around with a program to see if it breaks. No, it's a very deliberate, planned-out process. Programmers pick very specific inputs so they can watch how the program behaves and check if it does exactly what it's supposed to.
And this is just so important because without testing, all sorts of errors can just stay hidden in the code. And program might seem perfectly fine right up until a user enters something totally out of the blue. Finding these issues early on is what makes software safe and reliable for all of us.
So, to do all this testing, programmers need the right tools, or maybe the right ingredients. And that brings us to our third section. What is test data? You can think of it as the secret ingredient for really successful testing. Now, test data is really different from what a normal user might type in. It is deliberately chosen, it's controlled by the programmer, and it's all part of a plan. User input, on the other hand, is totally unpredictable. You just can't rely on it to find every possible bug. Now we know what test data is, let's break it down into the 3 main types that programmers use. This is pretty much the complete toolkit they need to feel confident in their code.
Right. To really put a program through its paces, there are 3 types of data, and each one is designed to check for a different kind of problem. They are normal data, boundary data, and erroneous data.
First up, we've got normal data. This is the kind of sensible, everyday stuff that a program should just accept, no problem. If you're testing a login, for example, this would be a real username and password. You're just checking that the basic core function actually works.
Next, we have boundary data. This is where things get interesting. This is data that tests the absolute limits of what's allowed. So if a program is expecting a number between 1 and 10, the boundary data would be, you guessed it, 1 and 10. So why bother with these edges? Well, this is where the sneakiest little bugs love to hide. For example, imagine a roller coaster app that only allows people between 10 and 50 years old. A tiny coding mistake, like using less than 50 instead of less than or equal to 50, could mean a 50-year-old gets turned away. Boundary testing is designed to catch exactly those kinds of small but really critical mistakes. And the third type is erroneous data. This is where you're deliberately giving the program bad input. The whole point here is to see if the program can handle it safely without completely breaking. This could be anything from typing text where a number should be to entering a value that's way outside the allowed range, like putting in an age of 200. It's basically a test of the program's defenses.
And this really gets to the heart of it. When a program is given bad data, the correct response is for it to reject it and show a clear error message. That's a success. Crashing is the failure. Being able to handle bad data properly is the sign of a truly robust program.
So you see, you absolutely need all 3. Normal data proves the basic stuff works. Boundary data finds those tricky little errors at the limits. And erroneous data makes sure the program won't just collapse when a user makes a mistake. Okay, let's bring this all back to what really matters for you. How does this apply to your exams? Let's focus on how you can show the examiner what you know.
In an exam, you'll probably get a scenario and be asked for some test data. You'll need to give examples for all 3 types, normal, boundary, and erroneous. But here's the crucial bit. You need to explain the program's expected behavior for each one, not write any code. The goal is to show you understand how this kind of testing leads to robust software.
Right then,
Let's do a quick recap of the key takeaways from this whole explainer. So we've seen that a robust program is one that behaves sensibly even under pressure. We know that testing is a deliberate process to check this, and it uses 3 specific kinds of test data: normal, boundary, and erroneous. And using all 3 is what makes for really reliable software.
In our next session, we're going to take all these ideas and apply them to some proper exam-style questions. It'll be a great way to make sure it all makes sense. But before we finish, here's something for you to think about. After everything we've talked about, which one of those 3 types of test data do you think is the most dangerous one for a programmer to forget to use, and why?